So here we have a default Proxmox 1.6 installation. We're going to be setting up clustering with DRBD. But the system that we're using, or the systems that we're using, the RAID controller only supports having a single logical volume. And so we're not going to be able to add one to set up DRBD with. So what we're going to have to do here is reduce some of the existing ones, move some things around, and make some space to do that. You do want to be sure that you do not try this on a system that's in production or one that you care about, because as you'll see, some adverse things can happen. When I did the installation, I used the line Linux space max root equal 10 space swap size equal 5, and you can see that if I run disk free, the root is around 10 gigs, and if I run free, the swap is around 5. So what we're going to be doing in order to make this extra space is that we're going to get rid of the data logical volume, which is taking up about 115 gigs and is almost entirely empty. Then we're going to shrink the SDA2 partition that volume group resides on, and then that'll make room for an SDA3 that we can use with DRBD. So what I'm going to go ahead and do is I'm going to go into or near the mount point for that LV, and I will copy the contents to root. And I'm going to go ahead and unmount the logical volume. So we have that. So now that that's unmounted, I can go ahead and remove its mount point, and then we'll go ahead and copy VZ back in. So there it is. So what we've done is we've unmounted this LVM, and we've put its data within the root LVM, the LV. So now that we've got that done, we can go ahead and LV remove dev mapper VE data, and if I run VG display, you can see that the logical volume is clearly gone because we have all of that free space in our physical volume now. Unfortunately, the physical volume and its underlying SDA2 is still taking up the rest of our RAID volume, so we're going to need to shrink the physical volume and the SDA2 partition in order to have space. So what I'll go ahead and do is PV resize, set physical volume size, and I'm not certain that this parameter does anything because we still have to make a resize within fdisk, but it was recommended from the documentation I could find to put this in. I'll go ahead and say 15 gigs to accommodate for our 5 gigs of swap and 10 gigs of the root logical volume. And I'll say it's dev SDA2. And you're going to see this is actually going to fail. And the reason it failed is that at install time, the system calculated that 15 gigs was equal to 3,840 physical extents, whereas now it thinks it's equal to 3,839. It's only one off, clearly some sort of a rounding error, but something we'll have to deal with in any case. Since it's only one off, then you can see that the physical extent size is 4 megabytes. The workaround in this case is to resize it to 15.004 gigs. And that will make it so that VG display shows that the entire physical volume and its volume group are 3,840 physical extents large, and that there are none free. Now we're going to need to go and resize the actual SDA2 partition to make room for SDA3. So I'll go ahead and fdisk dev SDA2. We can print the table. We will dev SDA and print the table. And you can see it is still using all the space based on the number of available cylinders. So we need to know what new size to make it. So what we'll do is we'll fdisk-L to list the partitions. This is device mapper 0, which comes up and is our swap. And you can see it's 652 cylinders. And then you can see here's our root, and it is 1305 cylinders. And so we're going to add those together. And then you want to make sure not to forget, which I've done in the past, that you are already using 66 cylinders at the beginning of the volume for your boot partition, SDA1. So that has to be accounted for as well. I believe these two together are 1957 is the number of cylinders. And adding in the 66, I believe it's 2023 cylinders. So what I will do is I'll go back in, I'll fdisk dev SDA, we'll print the table. There's our partition. We're going to delete partition 2, and we can see it's gone. Now we're going to recreate it, the primary partition, in of course for new. It's going to be partition number 2, and we're going to have the default. We're going to start it exactly where it was before, at the 66th cylinder. And then we're going to put in the new cylinder size, which is the 652 for the swap, the 1305 for the root, and the 66 for the boot. And I believe that's about 2023. I'm going to give it 2025, just to make sure I don't run any more rounding errors. And we'll print out, we can see it's done. Previously, the system listed this partition type as LVM, which I've heard may not actually be required, but I do want to make it look like it did before. So we'll go ahead and change the type of partition 2 to 8E, and that'll change it so that it's Linux LVM. At this point, we can go ahead and write the new partition table. And it knows that we are doing something we probably, on a production system, should not be doing, because it can't reread the partition table because we are using it. But in this case, it works out okay. One other thing you may want to do is open up your CFS tab and comment out the data logical volume so that the system does not hang when rebooting, not able to find that volume. At this point, I'll go ahead and shut down, restart, and go and do the other node, and then we'll move on to part 2.